Okay, for what we have in section 3.1 in Aleks, okay, we have uh, functions f of x and g of x in parts A and B, and it says to determine the compositions where we're looking at f of g of x and g of f of x, and whether f and g turn out to be inverses of each other. And for what we have in number 1a, okay, we have functions f of x and g of x, and both of these are set equal to 6 over x, whereupon x does not equal to 0. And for the compositions, now taking f of g of x and g of f of x, okay, we have, first of all, okay, we have with f of g of x, all right, so you have g of x is equal to 6 over x, and like what we did with compositions, okay, we're filling in for the input function, which had to be at g of x, okay, so you have 6 over x, and again we're going to operate in accordance with f of x is equal to 6 over x, so you have f of the input is equal to 6 over the input. Now instead of x, I have the input to be 6 over x. So in terms of following through, we're going to have not 6 over x, but 6 all over 6 over x. And dividing by a fraction will be the same as multiplying by the fraction's reciprocal. So you have 6 times x over 6, and so that will be equal to x. And for what we have in the case of g of f of x, now we have the input function to be f of x. Again, so we have 6 over x, and in terms of what we have in the follow through, okay, we have operating in accordance with g of the input equal to 6 over the input. We're going to have now with the input at 6 over x, you have the same bit of history to repeat, so you have 6 all over 6 over x. And this turns out to be the same problem all over again. So you have is equal to x, and so since the compositions both end up being at x, it's going to follow that f and g are inverses of each other in part A. In the crossover to what we have for part B, okay, we now have f of x is equal to x plus 4, and for g of x, okay, we have equal to negative x plus 4. And looking at what we have with the compositions, okay, so we have f of g of x. Again, we have g of x, we have at negative x plus 4. And in accordance with operating along the lines of f of the input equal to the input plus 4, we're going to have with the input at negative x plus 4. So you're going to have, in place of x, can we have negative x plus 4? And we have plus 4 once again. And what's going to happen in this particular case is that in following through, we're going to have constants to combine, and the output we're going to have at negative x plus 8. And for g of f of x, okay, so we have f of x as the input, so we have g of x plus 4. And taking what we have now, operating in accordance with g of the input equal to the negative of the input plus 4, it will turn out that we're going to have the negative of the quantity of x plus 4 plus 4, and this will translate out to negative x minus 4 plus 4. Negative 4 and 4 will cancel out, and this will come out equal to negative x. And since we have both compositions to be other than x, now for this particular set, f and g are not inverses. So in going back and taking what we have now, so we had from part A, okay, so we had f of g of x is equal to x, g of f of x is equal to x, and these are inverses of each other. In part B, okay, whenever we had f of g of x, okay, this came out to negative x plus 8. For g composed of f of x, we had the negative of x, and we had that f and g are not inverses of each other. And in checking, the result is correct. Okay, for what we have in problem number 3, okay, we have the corresponding one-to-one functions g and h, which are defined as follows. Now, a one-to-one function is going to be a function whose inverse is also going to be a function. And now we have for the function g, we have the ordered pairs as follows. Okay, so we have negative 9, 6, negative 8, 7, 6, 9, and 9, negative 9. And if I were to express what I have for the inverse, what was y will become x and vice versa. So in the rewrite, we're going to have the ordered pairs in the inverse at 6, negative 9, 7, negative 8, 9, 6, and negative 9, 9. Now, for the first part, okay, in the inverse, whenever we have x equal to 9, it's going to follow that for the value of the inverse function, this will be the y value whenever x is equal to 9. Okay, so you're looking at the y value whenever the x input is at 9, and we have in correspondence, okay, this is going to end up being at 6. Now, for what we have in the second part, we're looking at h of x equal to 6x plus 13. And it says to find out, okay, what the expression will be for the inverse. So we have h of x. Now this is going to be a functional notation for what we otherwise say is going to be y. So to say that h of x is equal to 6x plus 13, it's going to be the same as saying y is equal to 6x plus 13 in the x and y coordinate system. Now in looking for the inverse, I'm going to interchange the x and the y. So we're going to have in this statement, we're going to have that x is equal to 6y plus 13. And I'm going to solve this equation in terms of y. And this y is going to be in reference to the inverse of h of x. So in isolating y, I can take 13 away from both sides. So I have x minus 13 is equal to 6y. And we have with division by 6, I have x minus 13 over 6 is going to be equal to y. So I have that y is equal to x minus 13 over 6. And again, this expression in y is going to make reference to the inverse of h of x. So I have the inverse of h of x. This will come out to x minus 13 all over 6. Now, in looking at what we have for a function and its inverse, okay, so for h composed with the inverse at 1, and since we have h to be a one-to-one function, again, composition between a one-to-one function and its inverse at x is always equal to x. So it's going to follow that whenever x is equal to 1. Okay, so this will come out to 1. All right, so just taking what we have, typing in. So we have in this particular case, all right, so we got for, okay, now the inverse function of g at 9, okay, that was equal to 6. Okay, now we have with inverse function of g of x, whenever x is set to -9, it's going to follow that we have for the corresponding y value. Okay, that is going to end up at 9. Okay, so I misread the first part of the problem. I read the input as being 9 as opposed to -9. Okay, but again, so we have for the output, okay, that is going to be at 9. And we have for the inverse of h of x, okay, so we're going to have at x minus 13. And taking that expression, okay, we have dividing by 6. And for the composition between h and its inverse, and composition between a one-to-one function and its inverse will compose as the output, where the output is the same as the input, and we have to come out to 1. So we have upon checking, and the result is correct.